Hello again, class. We're going to talk briefly about probability distributions. We'll see a couple different videos with regards to this, and these are from classes previous week. So the first one we want to talk about is binomial, okay? And in its application, what we're trying to do is look at trying to find out the number of successes in n trials, okay? X is how we denote the number of successes, and n will be independent trials, each with a probability of success in this instance denoted as pi. Okay, so when we're looking at a discrete probability, it's written in this equation right here. So P of x equals whatever the number of successes we're looking at. Say it's 1, 2, or 3. So it's discrete there. Equal to the factorial here, we'll explain in a second. Then we have the probability raised to the number of successes, and that's, you multiply that by 1 minus probability raised to the number of trials minus the number of successes. Okay. If we're looking at a cumulative, it's written as such. So in this case, let's say that we have 5 independent trials, so n would be 5. And what we want to say is, okay, what's the probability that x is between 1 and 4? Okay? In this case, you would have to add up all the individual probabilities between 1 and 4 and sum that up, which we will not discuss further in this video, but we'll show in a separate video. So, how do we calculate this right here, factorial? So, for folks who haven't seen this before, this may look a little bit scary, but it's quite simple. All right. So, when we're looking at x successes and n trials, we have n factorial divided by x factorial times n minus x. So, in a case where n is 5 and x is 0, and in one of the assignments I gave you, n is the number of batches in a week, and x is the number of batches that have an issue after being accepted by QC. Okay. In this case, because we have zeros down here for factorials, 0 times 5 here, and this comes out to be 1. Okay. So from a question, suppose a civil jury of 6 registered voters is drawn from a community of 50% males. So the first question is what we're going to ask in this case here. What is the probability of an all-male jury? So what we're trying to do is we're trying to determine the likelihood of all 6 jurors will be male. So we use the following equation, all right here. And this is was shown a couple slides ago. So we know that n equals 6, that's the number of jurists. X equals the number of male jurists, and we have the probability P, which is 0.5. And this is just for this example, so the proportion of males in the population. Okay, so we start plugging in the values into the equation. So here's where we put the jurists here, so n, so we have n there, n here, n here, okay? The number of male jurists, okay? So 6 is right here, so this is just P equals, x equals 6, all right, that's where it goes. Also, we have x here, and x here. So we have 6, 6, and 6. And we put in the probability 0.5. They're right here, and we put them right in there. But we need to calculate this first. And that's the equation there. And in this case, because it's canceling out to 0 here, this becomes 1. reduces to this, 0.5 to the 6th, which is equals to 0.0156. So, given the data that we had, with a population proportion of 50% males, what is the likelihood of all 6 jurors being male? And that is very small, 0.0156. So, if we have n trials and we're looking for x equals n successes, how do we calculate it? How do we do that easily? Okay, taking the equation where x equals n, and that's what we had in the last case. So we had 6 jurists, and we're looking at what's the likelihood of all 6 being males. So, this becomes 1, right? So you cancel it out, and that's replaced by 1. This is canceled out as well, because if we have n minus 6, where x equals n, that becomes 0, and that becomes 1, okay? So all you're left is that. So whenever you're given a case where you have a probability and you're looking for the number of successes that are equal to the number of trials, it's simply the probability raised to the x. Alright, and we will discuss the cumulative method in a separate